CLV is important. And so here the point is that by using the CLV and by using the buy till you die model, we are calculating the CLV, and by using this, we can target the customer, we can make the strategy, we can make the appropriate plan to decide that for which customer we have to give different kind of ads, what strategy we can make them to make the good customer relationship and give them offers and many more things, whatever we can. And with that, we can also upgrade and upscale the business, because if some customer is very in low category, to make that low category to high category, so by using the CLV, we can do that, and we can focus on these customers also. In the CLV, there are three major blocks that CLV needs. First one is recency, second one is frequency, and third is the monetary. So recency is the age of the customer till the recent transaction, from the first transaction to the recent transaction. Whatever the age is there, that's the recency of customer. And frequency is the how often he makes the purchase of for the orders, how frequently he's purchasing, how frequently he's making the orders. That's the frequency. And the monetary is the average, that the value, the how much money he spends in every transaction, the what we can say average of the monetary of the orders or the transactions. Here we calculate the RFM score. As you can see the table, that customer IDs are there, and recency here it is showing 365 days. It means from the first transaction to that the recent transaction is 365 days. So here we can say that customer age is 365 days, that from 365 days he is still alive. So this is the age of the customer that we call the recency. And frequency, that how frequently he purchase the orders or products, like that. And in the monetary, that how much money he spent over the time of the transaction, average amount in every transaction. And this, whatever the data is showing here, that we took the sample data of the e-commerce data. So on that we showing these results. And whatever, and after that, here it is showing R, F, and M. These are the RFM value that we categorize in the range of 1 to 5. We put some parameters, and we split them into 1 to 5 range, and here the RFM value is there. And the one more important column is that RFM score. So RFM score is basically nothing but the addition of the R plus F plus M. So here we got the RFM score and the RFM level, that here it will shows that if the RFM score is greater than 11, greater than 9, so we put them in a different category. If RFM score is less than 9, so we keep them in a different category. So we categorize the customers according to their RFM score. Like here are the segments of the customer that we call the customer segmentation according to the RFM score. And on that also we will get this RFM score is based on the transactional behavior of the customer.
So here, like in terms of the whole customer base which we have got, for example, let's say I've got million customers, we are segmenting them into these 7 buckets. And those 7 buckets are based on not only one parameter or two, but all the 3 together. Either if the customer is very recently purchased, so he has been into the system for long and he has been continuously purchasing after a set period of time, let's say. So the recency will capture that part and say, okay, the customer is a loyal to us, so he is purchasing regularly from our side. And then if he's making many of transactions, so that will constitute the part where the frequency will try to capture how frequently he's making purchases, because more number of purchases being made, that is more loyalty and more interaction with our applications. Then third one would be around the monetary. So if even if the person is high on recency, high on frequency, but making very small ticket purchases, probably he will get a like a box over here, or segmentation maybe say need attention, where more hand holding is required to increase that monetary part. So this segment of 7 boxes is to divide your customer base based on each of these parameters clubbed together. So not one at a time, but all together. Any one of them, if the customer is missing out, how do we increase that? That would be helpful to know. What this particular part, what we want to add upon is, see, right now what we did with the RFM is to segment, to look at those customers, divide them into multiple, I would say, buckets from the ocean, which is each bucket have their own category. Now, how do we go about and predict, make actual predictions in terms of, let's say I'm looking for a customer, or on my revenue cycle is, let's say, quarterly. So in the next quarter, this particular customer, how many times he can come and buy from me, and if he's coming and buying, what is the average value which he's coming and buying, so that I can project the value or the revenue which I'm going to get from that customer.
So there are the two models that we are using for the calculating the CLV. One is probabilistic model, and one is the ML model. So right now we are focusing on the probabilistic model.
In probabilistic model, we try to fit the distribution for the RMS values. So the distribution is like beta geometric distribution or Pareto NBD distribution. For calculating customer lifetime value, we need two parameters or two variables. The first is a future transaction value, and the second is future monetary value. For calculating future transaction value, we can use Pareto NBD distribution model and beta geometric NBD model. And for calculating future monetary value, we can use gamma model. We have to use two separate models for calculating these two variables. That is, first one is transaction and the second one is monetary value. Similarly, by using Pareto and BG-NBD model, we can find the customer churn also. That means customer probability of customer alive. By using the BG-NBD model, here we calculate the future transactions. Here is a graph for which showing actual probability, actual transactions and expected transactions. And this another graph is showing the probability of customer is alive. Here we can calculate the probability of customer alive using the frequency and the recency values. That means if the customer has high frequency and the time when he bought product, that means time of his last purchase and the first purchase is very high, that means the customer is alive. So this is the probability of customer alive graph. Next.
Right. So on this graph, I want to focus on two parts. So on the left, the plot is like, as Tejaswini already mentioned, it's about if like the numbers on the x-axis I'm looking at like 2. So for 2, what I'm looking is actually the 2 transactions were made by approximately, let's say, 600 customers, and we also predicted that 600 customers will be making those 2 transactions. So that's kind of a thinking where actually what happened on our test data set and what we predicted. So that's about that. But on the right hand side, we are looking at 2 colors more probably. The yellowish color is the region or those customers which are actually alive, and we can say they are very active on our system. The ones on the darker shade are the ones which are kind of on a sleeping mode, where we wanted to bring them and move to the yellow part. But there's a band in between where these are the people who oscillate between, let's say, different platforms. So they will come to you sometimes very frequently and then suddenly shifts the mood and moves to the end of the platform. So these are the customers which are in actuality high value customers, but they require some handholding from your side to bring some incentives for them and make them more active on your platform. So the shift from the top right corner to the bottom left corner is what the business wants in order to increase this revenues.
Now here we calculate the customer lifetime value for next 1 month. By using BG-NBD model, we calculate the predicted purchase, and by using gamma model, we calculate the expected average spend. And by using both the values, that means predicted purchase and the expected average spend, we calculate the CLTV for next 1 month. So these are the values of CLTVs for different customers, or we can calculate CLT for each customer. So this is our model, BG-NBD model for customer lifetime value prediction.
Right. So here on this slide, like the key point I would say is like for every customer, like you seeing the customer IDs on the rows, and then these customer IDs are where we are predicting for each customer, like what is the in next month, 1 month, what type of revenue can we expect from these customers. That's the last column, which gives you the CLTV for 1 month.
So
Okay.
for everyone from sales, right? So important to understand how do we apply CLV. So like I said earlier, optimizing the return on investment when spending on acquisition, doing customer segmentation, and understanding who's your higher value customer, and then understanding what are the attributes of those customers so that we can focus on those attributes, understand what is working, what is not working. So there's a typical marketing analytics pitch. When we say marketing analytics, yes, we do data warehousing and whatnot, but then essentially the idea is how do we help you optimize your marketing? And this is like the step one of optimizing your marketing. And there are other things. There is, attribution of other components into CLV. There is attribution of the marketing channels, and then there is the calculating of the ROAS and all that. But this is like one of the important building blocks on how do you calculate and how do you predict customer lifetime value. Obviously the implementation will vary a little bit based on the domain. So for CPG domain it might be slightly different than the retail domain, than the gaming domain, or something else. But this is high level. If you have transactions, how do you use those transactions to calculate the lifetime value of a customer, either looking back, historical, descriptive, or looking forward. Right now, what the team displayed was probabilistic looking forward, but then there is more predictive looking forward as well using machine learning, which we can do in a follow-up session.